In this video, we're going to talk about surveying. And why do we survey? Well, this little picture illustrates something for us, doesn't it? No one wants two ends of a bridge that don't meet up, and no one wants a telephone pole or a power pole in the middle of the road. And I'm sure there's countless other examples of things that we wouldn't want in our own homes, businesses, offices, or wherever else. We need to get it right. We need to work out geospatially where everything is, where it should be, where it's going to be built, to make sure we're not breaking any laws, to make sure we're doing it safely, and to make sure the right things are going in the right place and not in the wrong place. So what is surveying? Well, surveying, or geomatics as we sometimes call it, involves gathering, storing, processing, and delivering spatially referenced information. So we have a number of tools to do this, including the actual measurement tools that we use, and also the computer tools, the software that we use to be able to store and present and process this data as well. When we're surveying, we're typically looking both at man-made and natural features, because depending on our surveying application, we may need to work in with both of them, or be replacing one of them, or making modifications to one of them. So we typically will look at both of those sort of features. And when we process this data, we can create detailed drawings, maps, planning diagrams to allow us with our engineering construction projects or whatever it happens to be. And typically before any big engineering project, a land surveyor will come out. And the job of the land surveyor is to survey the area and work out where everything is, where the boundaries are, where the easements are, where everything's going to be and where it's all going to be laid out. So why are we surveying? What's our purpose then? Well, there's a number of different purposes, including and fundamentally to produce detailed plans of the environment that we're operating within, including things like a level survey where we're looking at contours and slopes. We might want to work out how much we need to cut away from something to get our building in there, or how much extra fill's required to build up a level and make it level. Now, this might be for the purpose of construction. We might also be looking at trying to identify hazards, easements, boundaries, all of those sort of things so that we can safely build within a particular area. If we're filling a particular area, the surveying will allow us to work out how much fill that we need, or how much fill we need to remove from a particular area to get it level in the way that we want it. And when we're looking at starting our construction work, we want the area to be surveyed to understand what we're working with and to be able to monitor the ground and looking at how it's going to change over time with that construction. Now, fundamentally, there's two types of surveys that we do. One is our plane surveying. And in our plane surveying, we're essentially treating the area as a flat plane. And our other type is the geodetic surveying, where we're considering the curvature of the Earth in there. Now, obviously, we know the Earth's curve. We know we've got this spherical pattern, or an elliptoid, as we'll look at it later on. And so we know that there's this curvature there. But if we're working on an area that's relatively small, we can approximate this to a plane rather well. We'll get very little curvature over hundreds of meters or even a few kilometers. That curvature becomes much more pronounced with much larger projects. And so for our plane surveying, where we might have up to 250 square kilometers, we assume it's a plane. We have 3 points, and those 3 points on the Earth's surface can make up a plane. Now, a geodetic one, obviously more accurate, but we use this for our largest surveying areas when we need to take in the curvature of the Earth, for example. So places we'd use this are very large projects where we might be surveying a railway line or something like that, for example, which might go for dozens or hundreds of kilometers. Now, besides looking at those plane surveying and the geodetic surveying, there's lots of different applications around surveying that we use. Obviously, we have our engineering surveying, which we've already talked about before we do any construction or build projects or anything like that. We're working out where everything's laid out so we can design it properly. Another area we use surveying is within topographics, creating topographic maps, looking at where we put contour lines and things for people when we're designing bushwalking paths, national parks. We're working where all the lakes and rivers, cliffs and hills and all of those sort of things are, which help us in navigation for land management. We can also do surveying for property management, cadastral surveying, where we work out where property boundary lines are for a house or a business or a building or something like that. What's yours and what's not yours and your neighbours, for example. Another place we're doing surveying is not so much on land, but on water, and working out what's under the water. What do the coastlines look like? What do the seabeds look like? What obstructions are there? What other things are there? How's water flowing within the environment? Here we're doing a hydrographic survey. We can also do surveying with photogrammetry, with satellite imagery and things like that. Here we're doing it with an aerial approach rather than a ground-based approach. And sometimes we refer to this as remote sensing. Another big place within surveying is mine surveying, whether it's underground mines or open cut mines, working out how much dirt or material that we have to extract, working out the area of this mine, working out how much and how extraction's going. All of those things can be surveyed as well. Sometimes we're surveying for cartography, creating maps and creating GIS systems where we're trying to create maps and digital maps that we can actually use and share around, and maybe even overlay GPS data or something over to enable people to navigate or do whatever job they need to do. And geodesy surveying, where we're looking at the Earth as a whole, taking into account things like the Earth's gravitational field and trying to create a common reference frame system, something like WGS84, which we use right around the world, combined with GPS data to allow navigation systems and navigation instruments to localize us. Now, when we're talking about surveying, sometimes you might come across these things here, which are called survey marks. Basically, these are highly accurate mark points that have been surveyed out by someone, and they can be seen as basically a start location, a true location that we should know the location of. There's databases, and different countries and states will have different databases which carry all these marks with information about them. For example, their latitude and longitude, their altitude, where they are, what type of mark it is, how accurate they've been surveyed to, and all of those sort of details. Over here, we've got the database of the Victorian one. And so you can actually look and see a whole lot of marks. This is just around the La Trobe campus, a whole lot of marks that have been surveyed out. Now, if you click on any one of these, it will show you the GPS location and give you a bit of a description of what the surveyed point is. Like it might be a nail in a footpath or something like that, or it might be a metal plate that's got some writing or something on it. That will help you when you're trying to locate it and find it. So at least you know what you're looking for. Now, surveying's not a new thing. Surveying's been going on by thousands of years by many different people groups, from the Sumerians, Egyptians, Hebrews, and for multiple reasons. I'm trying to measure the extent of the flood of the Delta River, for example, and mostly though for property management and large building construction projects. For example, the pyramids. We've seen pictures of various ancient surveying equipment, things like plumb bobs, which we still use today to work out a straight line down to the ground based on the Earth's gravitational field. Here, for example, some ancient Hebrew writing from the 5th and 6th and 7th, somewhere around there, centuries BC. I'm talking about measuring out east side and west side, north side with reeds as a form of measurement. Basically, there were different forms of measurement, from knotted ropes to measuring sticks that were used for these surveying operations. And there were also laws imposed around moving landmarks. Thinking about our survey landmarks before, well, ancient people had different landmarks. It may have been a well or a tree or some poles or something in the ground to mark out where their territory was, where it had been surveyed to. And so there were penalties involved if people would move those landmarks and essentially tried to steal someone else's property in terms of their land. And in terms of surveying, if you look from the sky, you see things like the pyramids, and here we have 3 pyramids lined up, pointing, well, square with north, and essentially nice surveyed out shapes. And this was done not with total stations and things like that, but very rudimentary equipment that's been used for thousands of years. So as I said, surveying's not a new thing, but it's an important thing, particularly in engineering, when we're trying to do our construction and management and understand the world around us correctly.